Hello everyone, this is the second video of the series of quick concepts in which we are going to discuss the second application of multiplying factors. Before you continue with this video, make sure you go through the first application of multiplying factors which is explained in the first video of this series. So let's start with the second application of multiplying factor. Over here the concept is when the multiplication of two things remains constant. For example, a into b is equal to constant, and the type of question over here is the price of petrol increased by X%. By what percentage should we decrease the consumption to maintain the same expenditure on petrol? For example, we know that price into consumption is equal to expenditure. Now price of petrol is increased by X%. Now we want to keep expenditure to be constant. For that we need to decrease our consumption. So by how many percentage we are supposed to decrease our consumption, that we need to find over here. So before this, let's understand the concept behind this everyone. Now let's assume that a into b is equal to k. So now let's assume the value of a increases by a fraction x divided by y, and we want to keep the value of k to be constant. So the value of b should decrease by how much fraction, that we need to find. So over here we know that, as we learned in the first video of this series, in the first application of multiplying factor, a into b is equal to k. So multiplying factor for a into multiplying factor for b is equal to multiplying factor for k. So as we want to keep the value of k to be constant, so the multiplying factor for k becomes 1. So now the value of a increases, by x divided by y, so the multiplying factor of a will be 1 plus x divided by y. So now to keep the multiplication constant, we need to decrease b. So let's say the b decreases by fraction p. So the multiplying factor for b becomes how much? 1 minus p. We need to find the value of p to be how much? So let's do this. This is equal to how much? X plus y divided by y into 1 minus p is equal to 1. So the value of, so over here the value of 1 minus p is equal to y divided by x plus y. The value of p is equal to 1 minus y divided by x plus y. So the value of p is going to be how much? X divided by x plus y. So from this what we can conclude, let's have a look at it. If a into b is equal to k, or if a into b is equal to constant, if we increase the value of a by x divided by y, to keep the multiplication constant, we should decrease b by x divided by x plus y. This is the direct formula we can use over here. So let me write this formula again and let's see how we can use this concept in the question. So the formula that I wrote over here is when a into b is equal to constant. If I increase the value of a by x divided by y, we need to decrease b by x divided by x plus y. So how we can use this concept in this question, let's have a look at it. Let's read this question carefully. The price of petrol has been increased by 25%. What percentage should the consumption of petrol decrease by to maintain the same expenditure on petrol? So now we know that price into consumption is equal to expenditure. We want expenditure to be constant. The price is increased by 25%. It means the price is increased by 1 by 4. To keep this multiplication constant, we need to decrease consumption by how much? 1 divided by 1 plus 4. If the value of a increases by x divided by y, the value of b should decrease by x divided by x plus y. Remember, you can remember like this: while decreasing, the denominator should be greater, the numerator should be same, and the denominator should be addition of numerator and denominator. So if price increases by 1/4, the consumption should decrease by 1 divided by 1 plus 4, that is 1 divided by 5. The consumption should decrease by 20%. Let's have a look at one more example. In this question, the price of petrol is increased by 37.5%. By what percent should the consumption of petrol should decrease to keep the expenditure same? So again, price into consumption is equal to expenditure. This expenditure we want to keep it constant. Price is increased by 37.5%. That is nothing but 3 divided by 8. So price increases by 3 divided by 8. So consumption should decrease by 3 divided by 3 plus 8. So 3 divided by 3 plus 8 is equal to how much? 3 divided by 11. 3 divided by 11 is how much? 3 into 1 by 11 is 9.09%. That is equal to 27.27%. So if the price of petrol increases by 37.5%, the consumption on petrol should decrease by 27.27% to keep the expenditure on petrol to be constant. Now, third example. Over here, the price of petrol decreased by 18.18%. So again, same formula, price into consumption is equal to expenditure. We want to keep the expenditure constant over here. So price of petrol is going to decrease by 18.18%. That is, price of petrol is going to decrease by 2 divided by 11. So consumption should increase by how much percent? So over here, this value is nothing but 2 divided by 11. This is equal to 2 divided by 11. So if you compare this, x is equal to 2 and y is equal to 9. So the consumption should increase by x divided by y, that is 2 divided by 9, that is equal to 22.22%. So if price of petrol decreased by 18.18%, we can increase consumption by 22.22% to keep the expenditure on petrol to be constant. Now the question number 4. While traveling from home to office, if speed is increased by 36.36%, by what percent travel time will decrease? So over here, the distance is constant. The formula we know is equal to speed into time is equal to distance. Over here, distance is constant. We are traveling from home to office, the distance is constant. The speed is increased by 36.36%. It means the speed is increased by 4 divided by 11. 36.36% is nothing but 9.09 into 4. So if we increase speed by 4 divided by 11, our travel time will decrease by 4 divided by 4 plus 11. Our travel time will decrease by 4 divided by 15. Now 4 divided by 15 is equal to how much? It is nothing but 3 by 15 plus 1 by 15. We know 3 by 15, 1 by 5, 20% plus 1 by 15, 6.66%, that is 26.66%. Our travel time will decrease by 26.66% if we increase our speed by 36.36%. Similarly, let's do one more question. While traveling from home to office, if I decrease my speed by 75%, by what percent travel time will increase? Let's have a look at it. Over here, again the same formula, speed into time is equal to distance. Distance to be traveled is constant. Now speed is decreased by 75%. That is, speed is decreased by 3 divided by 4. Now this is 3 divided by 4. So if you compare this, you can see that x is equal to 3 and y is equal to 1. So we should So our travel time will increase because our speed is decreased. Our travel time will increase by how much? X divided by y, that is equal to 3 divided by 1. So if we decrease our speed by 75%, our travel time will increase by 3, that is nothing but 300%. This is how we can use this concept over here. After this, the same type of question with a small variation. The question is, if I travel at 7/5 of my usual speed, I will reach my destination 8 minutes earlier than the expected time. Find the time taken to travel if I travel with my usual speed. So over here again the same formula, speed into time is equal to distance. So over here I am traveling at 7/5 of my usual speed. It means I increased my speed by 2/5. So my travel time will decrease because distance to be traveled is constant over here. So my travel time will decrease by 2 divided by 2 plus 5, that is 2 divided by 7. So the decrease in travel time is 8 minutes. So from this what we can conclude is 2/7 of usual travel time is equal to 8 minutes. So from this what we can conclude is the usual time, if we travel with the usual speed, how much time we take? 7 into 4, 28 minutes we take. Let's try one more question of the same type here. If I travel at 5/7 of my usual speed, so again speed into time is equal to distance. The distance traveled in both the cases is constant. I am traveling at 5/7 of my usual speed. It means I decreased my speed by 2/7. So this is 2/7 over here. So I should increase my speed by 2 divided by 5 because x is equal to 2 and y is equal to 5 over here. I should increase travel time by 2/5 and my travel time increases by 10 minutes. I reach 10 minutes late. It means my travel time increases by 10 minutes. So 2/5 of usual travel time is equal to 10 minutes. So if you solve this equation further, so you will get usual travel time as 25 minutes. This is how we can use this concept in the questions of time, speed and distance.